So secant and tangent lines, I've told you informally what these are. This shows up in the notes at this point, so we'll just make sure we define them. A secant line is a line that intersects a circle at 2 points. So they have a picture that you can just barely see. It's going through there and there, 2 points. Tangent line is a line that intersects a circle at 1 point. And so you have this little picture. It just barely glances the circle right there. Okay? So we're going to look at a couple of theorems. If this was a full geometry class, you had geometry all year, we would have worked up to this probably in the spring, and we would have done a full-blown proof using other things we knew on why these work. We don't have time for that, so you're getting sort of an abbreviated version. We're just going to get to the point. So we're going to draw a picture to do sort of what this theorem says. So we have a circle, and we're going to draw a radius r to the circle. So I'm going to call this circle A. So the center's A, and we're going to say that this point over here is B, and then R is the radius. Or actually, I don't even know if we need R. Let's just do A and B. And then we need another point on the line to name it. So let's put point C over there. So this line, BC, is tangent. So we're going to say BC is tangent to segment, or actually tangent to circle A is what I'm trying to say, is tangent to circle A. So that's sort of the given information. If that's true, then AB is perpendicular to line BC. So anytime you have a tangent like this that meets up to the edge of a radius, it may have just blipped out. Sometimes our connection's not so good. She's going to watch the videos anyway because you can't hear through that thing worth of crap.
Oh, I understand now. No,
so basically what that's saying is if this is tangent to this point at the edge of this radius, then this is going to be perpendicular. We can put a little right angle mark in there. And that allows us to find some other things, which we'll see on the examples. So there is a way to prove this. We haven't done enough background to kind of fit all that in. And I just figured out today we could have done an interactive proof on this, but I'm still figuring. For tomorrow, we're going to use our iPads, make sure they're charged. We're going to do some things by hand, like paper, pencil, like little diagram drawing things, and then we're going to do something on the iPad, but I'm still figuring out how the website works. There's an app, but I don't know that I have time to get it downloaded to everybody's iPad for tomorrow. It seems to work on Safari, so we're going to try to see why some of these things work. All right, so in each figure, line AB is tangent to, and this is supposed to say circle O, and the symbol got it. So circle is a circle with the center point on it, which is strange next to the O because it looks like I'm saying oh, ooh. So, but it's circle O. That symbol didn't copy for some reason. I think it's because I opened it with a newer version of PowerPoint and the symbol got lost somewhere. So it's telling us that this is tangent to circle O. And you can also see that there's a radius from the center O out here to point B. It says find the value of x rounded to the nearest tenth. So from that theorem I just gave you, if this is tangent to this, and here's this radius, then that is a right angle. And they've given us the 8 here and the 5 here, which would be the legs of a right triangle. So how could we find this side then?
Oh God. You have to use
Pythagorean theorem, we're going to find the hypotenuse, exactly. So a squared plus b squared equals c squared. Remember that c is the hypotenuse. So you just do 5 squared plus 8 squared equals c squared. So that is 25 plus 64. And we get this, so we get, I'm skipping ahead, I don't mean to. So we get 89 equals c squared. And then what do we do? Square root it. So the square root of 89, we could simplify that, but I think I'll just do a decimal for right now. It's approximately, because it says to round to the nearest tenth, so it rounds off to 9.4. So knowing that something's going to be perpendicular allows us to use the Pythagorean theorem. It does get a little bit tougher than that with some extra steps. We have a couple of easy ones before they throw something crazy at us. Okay, so if we go to the next problem, they give us that this is 20 and this is 21. This would be a right angle. But this x is only this little piece right here. So we're going to have to find the hypotenuse C first. And then remember that this distance from O to the edge is the radius. So if my radius is 20 over here, this radius over here would also be 20. So we're going to use that to figure out what the little piece is. I don't know, I'm drawing this not so good. So this x is just from here to the edge of the circle. Maybe that makes more sense. All right, so we're going to start by finding what this whole length is from O to B. So I'm going to have 20 squared plus 21 squared equals C squared. You get 400 plus 441 is C squared. We have 841 equals C squared. If we square root 841, we get C. And 841 is a perfect square. If you square root it, you get 29. So this whole distance from O out here to B is 29. And because they give us the radius over here to the edge of the circle is 20, we can copy that over here. So that's 20. So what plus 20 makes 29?
6. 9.
Turn it upside down, 9. So you just take 29 minus 20, which we can probably just do in our heads, and we end up with 9. So x is 9. So that's a little bit of an extra step, but it's not that bad. It's like a little subtraction. And I will tell you with a lot of geometry things, if they give you a radius and you put it on every other radius in the picture, a lot of times that does help solve things. All right, so let's look at this one. So this is the same kind of problem we just had, except instead of being a little piece, this out here is a big piece. Remember, if this is 8, this little piece, this little radius out to the edge of the circle is also 8. If you just mark that in the beginning, then you don't have to think about it at the end, and it just makes... So this distance right here is 8, from here to here. Because they're giving us that distance here. If it's a circle, it's going to be 8 all the way around, from the center to the outside, because that's your radius. And they're still wanting this piece that's on the outside. So C would be the entire hypotenuse. So here's my right angle up here. It's always going to be on the edge of the circle where the tangent line meets that radius. So we'll have 8 squared plus 25 squared equals C squared. So we get 64 plus 625 equals C squared. If you add those, you get 689 equals C squared. Square root, and you get C. So 26.2 is, if you round it off to the 10th, is C. Oh, you're right. I forgot my step after I just said don't forget.
No.
So that's all, the whole thing is 26.2. So then I have to subtract off the 8, and we get 18.2. The bad thing is I even have the answer sitting over here. But I didn't look at it because I wasn't cheating. I was actually working it out. All right. So don't forget they want this little piece that's outside the circle. All right. So that's the tangent theorem. It's really not super exciting. It uses Pythagorean theorem. And I'm going to give you another theorem that uses Pythagorean theorem today because I just figured we'd cover all of that in one lesson. And that's called the Radius-Chord Theorem, or sometimes it's called Radius-Chord Theorem. And so I'm going to give you a circle, the center, and we're going to draw a radius that goes up to the top. I'm going to call this circle A. I'm going to call this point up here B. And then we're going to draw a chord that goes across like this. I'm going to call it C and D, and this little point in the middle I'm going to call E, where they cross. And so basically you have that if, actually, I did that backwards. Okay, so this is E, and we're going to say that these are forming a right angle. So if segment CD is perpendicular to segment AB.
You're just doing letters. Like, how are you writing that?
Because we're just writing letters.
Yeah.
Yeah, instead of writing out, I actually have a paragraph on my old notes, and since I know you guys have seen this notation before, I'm using it to make it shorter. So CD, this chord right here, is perpendicular to AB. Then CE equals ED, or DE, whatever you want to call it. And we leave the, remember you leave the little segments off because those are distances. So basically it bisects the chord. So these come out the same. We can mark that on the picture. This and this are equal. And I think you can also prove it backwards. If these are equal, then that's a right angle. And it's interesting how you prove it. You use some congruent triangle stuff. If we had more time, we could have done that one. But we're trying to get in all this geometry in a very short period of time. So that's that. So if we go to the next page, we're going to see some examples. So it says circle P has a radius of 5 inches, so they marked 5 right there. And PX is 3 inches. So from here to here is 3. So we could think about that for a second. If it's 5 all the way to the edge from P here, it would be 5 all the way here. So you could actually go, okay, well that'd be 3 and that'd have to be 2 because that has to add up to 5. Just as a side note, when I see pictures like that and I know that that's my radius all the way around, I like to fill that in. Sometimes it's helpful, sometimes it's not. And then it says find AB. So I don't think I really needed it for this problem, but sometimes you do. I'm going to zoom in a little bit more because that's just so tiny. So this would be the hypotenuse, so that's C. We have 3, I'll call that A. And so AB is all the way across. I can't find that in one step, but I could figure out what this little distance is here from A over to X using Pythagorean Theorem. It's going to be a little bit different because they're giving us the hypotenuse. So that goes on the other side. So we will have 3 squared plus b squared, or whatever you're calling it, equals 5 squared. So 9 plus b squared equals 25. If you subtract 9 from both sides, b squared is 16. So if we square root that, you end up with 4. So what essentially that means is this distance right here is 4, and they went from A to B. So you're just going to take 4 times 2, or 4 times 4, and get a distance of 8. So we're just extending some things we know a little bit. We know how to use the Pythagorean Theorem. We just now are learning that when it's set up like this, and they're telling you that these are perpendicular, that we know that these are the same. We couldn't do that without knowing that they're the same. Okay, so let's look at the next slide. I think these might have gotten out of order, but that's okay. It says name 2 pairs of congruent segments. So the first thing that's really easy is you could name all of the radii. So PC would be congruent to CS, which is congruent to CR. So that's more than a pair, that's a trio. And then what other things did we say would come out?
PQ, QR.
Good. PQ would be congruent to QR. You guys did pay attention. Good job. And it says if PR equals 8, find PQ. So if it's 8 all the way across, they want just half of it. So it would have to be 4 and 4. So that's pretty straightforward. Sometimes on your SATs, they'll give you this big complicated picture, and they'll be like, and if you know a little bit, and you can figure out, oh, they're actually just wanting me to do that, it's not as hard as it looks. Okay, so let's go down and do some other problems. And I reused the same picture over and over. I apologize for that. That's laziness when I was using this as a PowerPoint, because you can copy and paste. All right, so it says if CQ equals 10, so I'm going to write that on here. CQ is 10, and PR is 24. So if it's 24 all the way across, I'm going to go ahead and split that into 12 and 12. Does that make sense?
Yes, it does.
Good. It says find the radius. So I have two right triangles I could use. We get to choose. Doesn't really matter because they're both going to have 12 and 10. And we're trying to find the hypotenuse. So 12 squared and 10 squared equals c squared, or whatever you want to call this. Right here, you could call it x. So we'll get 144 plus 100, which is 244. And then if we square root that, we'll get c. So the square root of 244 is about 15.6.
Yeah. Are these yours?
Yes.
Okay.
I tried to print them yesterday. And
They were on the
just
copier when I
now
got.
came through.
No, they were on the copier this morning.
Oh.
I just.
They didn't come through when I...
When you sent them.
I know, they were in the ghost of the machine somehow. Thank you. All right. That's for this class, actually. These are circles for tomorrow. All right, so let's do the next thing. All right, it says if the radius is 9...
Oh, golly gee.
So the radius is 9 would be this radius, and that whole radius in there, which is harder to mark. Oh, and it says QS is 1. So if this is 1, but it's 9 all the way through, then that's 1, and this is 8, because that adds up to 9. It says find PR. So PR would be all the way across here, so let's call this little distance right here x. Set up the Pythagorean Theorem. So x squared plus 8 squared equals 9 squared. Does that make sense?
Yep.
Okay, so
Could you
x
use
squared.
the big triangle? Oh, that's not a right angle.
Yeah, so that's not a right angle for sure. So x squared plus 64 equals 81. We subtract 64 from both sides. We get 17. Square root x squared, square root 17, and we get about 4.1 for x, but then it wants PR, so I'm going to have 4.1 times 2, which is 8.2. And they didn't give us units on anything, so the other thing you could do is just leave whatever number you got on your calculator for the square root of 17 and take that times 2 in case we do have a little rounding stuff going on there. Okay, so let's see if this is anything different. So it says PR is 18, QS is 44. So if QS is 44, we'll split it in half.
Is R that middle point?
Make that 22. Huh?
Is R the middle point?
R, I think, is supposed to be that point right there. Yes. It's a little ambiguous, but I think they were intending it to be there. I copied this one out of a book. And maybe before I blew it up, it looks more obvious. I don't know. And then it wants to know PQ, so that's just C. So just another Pythagorean Theorem. 18 squared plus 22 squared equals C squared. I should have given this to you guys as the practice problem. 324 plus 484 equals C squared. So we get 808 equals C squared. Square root 808. We get approximately 28.4. And I'm going to change that equal sign to approximately because it is rounded off. All right. So this next one, when I copied the picture, I didn't get all the letters on here. L is supposed to be this point over here, and there's supposed to be an N over here. And so I think maybe that's why I didn't do these as practice problems last year. I'm like, why didn't I just do that? But that's why. So this is JM is 24. So here's 24. KM is 42. So 42 all the way down. So it'll be 21 and 21. And it just says JL equals, so you'd make that your X. I'm going to let you guys set up the Pythagorean Theorem and do that as kind of a practice problem. I should have just given you the whole thing, but since the N was missing, I wasn't sure if that was a good idea.